Hello, and welcome back to my Kubernetes series. In this video, we will be going through the setup of an email server, which will provide IMAP and/or POP3 functionality. I am interested mainly in the IMAP features, which I will be focusing on. I found quite a few Dovecot implementations for Kubernetes. None, however, fulfilled my requirement. My major requirement was I wanted to be able to use config maps and activate different modules once I was comfortable doing so. So I decided to build a container based on an Alpine image and added all the required packages for Dovecot. A second requirement was to build a deployment that allowed me a master-to-master synchronization. What does that mean? I will deploy 3 pods of Dovecot, as I don't want to take care of managing the traffic to a specific pod each time a user wants to access their emails. I need to make sure each pod has the same data. There were 2 options to accomplish that task. Number 1, through access to the same storage, or number 2, through synchronizing the data with the 2 other pods. As I also wanted separate storages for each of the pods, my only option was to establish a synchronization between these Dovecot pods. That way, I have copies of the emails in the different pods, and even if one pod fails, I still have the emails sitting in the other pods. In such a setup, I don't have to be worried of losing data. Worst case, I can recover the data through my storage backend, which will be through my NFS server, and can copy that data into a new container. There is one difficulty in that process. The synchronization, which happens through lsync, I have to exchange keys. If one pod fails, I must restart all of them, as the key in the restarted pod will be different from the pod that crashed. At this moment, I have not been able to modify my deployment and am not able to just restart that one failed pod and update the still running ones with the new key. This issue also impacts the scalability of my deployment. I am sure there is a way, there always is. So as you can see, I still have some work to do to figure that piece out. To only restart one pod and update the keys without having to restart my whole email server. That being said, in this video I will focus on Dovecot. We will review the container build. I will walk through the config maps that we need and the ones that are optional. In the next part, I will discuss the synchronization setup and build that container. I will review the configuration maps that we require for that synchronization container and explain how the sidecar container works. In the third part, I will bring these 2 deployments together. I will walk through the Dovecot deployment, show how both containers are set up, and what other components we need to make these items work together. Before we get into building the container, let's take a look at the packages. As I usually work with Debian, installing Dovecot on Alpine was a bit different. Searching for a list of Dovecot packages for Alpine brought me to the page you see on your screen right now. This list was absolutely incredible for a few of my builds. However, if we look for the Dovecot packages, we find a few options that we can install. I reviewed the packages, made sure I understand what they are used for, and install the ones I require. Let's now switch over to my container builder and take a look at the build file for the container and additional files we need to make Dovecot work. Getting into the containers folder and entering Dovecot, we take a look at the container build file. The container is based on an Alpine image, and I update and upgrade the packages. Then I install the packages I need. Beyond the Dovecot packages we took a look at, I installed curl bash the MariaDB client, which is crucial for our implementation to use the database. In video 12.3, we established that database table to manage the users that will have an account on this instance. Additionally, I installed the CA certificates and GNUPG. We remove the folders that are created by the installation of dovecot and create empty ones. We copy the entry point sh file into the container and make sure the script can be executed. We will take a look at that script in a second. I create new group called vmail with a group ID 5000. I create a new user called vmail, which I add to that group I just created. Despite having created the user with the H flag, which should prevent the creation of a home directory, I also replace the home folder in the passwd file with dev null, just to make sure. Then I create a folder called vmail in the root of the file system. That is where all emails will be stored going forward. I set the folder to be owned by the vmail user. I have the ports outcommented, which are not necessary. We will implement the container in Kubernetes. The ports are defined in the deployment. Next, we define the entry point to be the file entry point sh, which we copied in line 9. Then I set some labels and commit to the build. That is the container. We will exit this script with write and quit. Let's take a look at the entry point.sh file. Vim entry point.sh. This script is super simple. First things first, we make sure the vmail folder is owned by the vmail user. Second, we run dovecot. The config file that the script is referring to is the dovecot.conf, which is handed to the container through a config map in Kubernetes. And that is it. We exit the file with write and quit, and we're going to build the container with /dovecot new sh. The build should not take very long, so let's observe, and once complete, we'll push the image to our repository. Let's verify the container is built with build images. We can see the dovecot container is built 28 seconds ago and at a size of 138 megabytes. As the container is built and pushed to my image repository, let us start walking through the config maps. I will not walk through all of these maps. There are tons and tons of customization options, and I will only walk through the ones I'm using. But I will highlight how to activate others. Talking about every single config map does exceed the scope of this video. Please feel free to visit dovecot.org and review the documentation. There are different examples that might help you to configure the right setup for your specific implementation. With that out of the way, let's switch over to Arcade as master and start walking through the config maps we need for the setup of dovecot. On my master, I navigate to our K8s setup folder and create a folder with mkdir 11 dovecot and bring in the first file, the dovecot.conf. This file is the main configuration file for dovecot. If you remember back when we built the container, this file was called by the entry point script we defined. Without this file, dovecot will not run. So let's now move all the way to the top and start walking through the file. As this file represents a configuration map, we start off with a typical structure, API version and kind, followed by the metadata. We call the config map dovecot-conf and deploy said map in the namespace mail server. Then we define the data, which is called dovecot.conf. You can see the file is quite well documented and references the documentation on dovecot.org. Down in row 31, we activate the different protocols we want to use, which are the IMAP and lmtp. IMAP will provide an IMAP mailbox, similar to what you will find in a mailbox from Google, Microsoft, Yahoo, or any other mail provider. The LMTP protocol is important for us. Why? Emails that we will receive through fetch mail are handed off to Postfix. Postfix will check if the user exists and hand the email off through the LMTP or local mail transport protocol to Dovecot, where the message will be saved in the inbox of the user. As soon as we have Dovecot deployed, we will test this setup, and I will show that process along the logs of Postfix, Dovecot, and fetchmail. Next in the config file is the inclusion of all files that end in .conf in the folder user share dovecot protocols. Next, a less important item, but something that helped me during testing to figure out if my container started up properly, the login greeting in line 50. The login greeting in line 50 is shown as soon as you log into your mailbox through Telnet. This message shows up versus the standard. That helped me figure out if I was actually signed in or if something was still off. Nothing important, but quite helpful during that testing process. Following the login greeting, we have the login of trusted networks. This entry is important as my logins will all come through the Kubernetes cluster, and the services do have an address that starts with 10. To allow logins to these different services in my cluster, I am specifying these addresses here. Next, we scroll down and get to the dictionary settings, which serves Dovecot as simple key value pair databases. The section is all outcommented, but you can specify different backends in here that serve Dovecot these key value pairs through flat files, LDAP, Memcached, or the like. You can, for example, get limit quotas or login via LDAP. This functionality requires you to specify an additional file, as shown in the example in line 99, in which you must specify how that data is to be retrieved. Quite complex but powerful at the same time, but nothing I will be using right now. Just keep in mind, this section is here if you want to use and implement it. In my case, I would be using an SQL database over a separately managed file. Alternatively, you can also specify in your local Active Directory some of the details you want to use for limits. The challenge with SQL is you must establish the database connection through a proxy, as per the advice on the Dovecot website. Link is on your screen right now. You could even use Redis to make your server more responsive, all beyond the scope of this video. There are some great examples on the Dovecot website, particularly on how to set these dictionaries up. Please have a look. I have the link in the video description. Enough of that, let's move on. Next, we include the files that are stored in our case mounted in the location conf.d and end in .conf. We also include the local.conf. That file for me will not be used. I will configure the conf files in the conf.d folder. At the end of the file, I added a few things to the setup of Dovecot. These two service entries specify your vmail user as the stats reader and stats writer. Not having these options caused errors in the logs. Once I made the vmail user a reader and writer for these stats, these errors disappeared. And that is the end of this file, which we will exit with write and quit. We continue looking at the files of dovecot's main directory. And we will start off with the dovecot-dict-auth.conf.ext.yaml. We start off with the same structure of API and kind. Then we specify the metadata with the name and in which namespace are we going to deploy this config map, and then we have the file definition. As this file was created during the installation of Dovecot, I created a config map to have it available should you want to configure it. Nothing for us really to go through, as in my deployment I will not be using this kind of authentication. The reason is I am using the database table to authenticate users. So let's save and quit and move on to the next file, which is the dovecot-dict-sql.conf.ext.yaml. Bringing in the content, the structure is the same as per the previous files. I did not specify any limits or quotas for which I would use this file, but if you want to investigate its usage, please follow the link in the video description. So we will just write and quit this file and move on to the next, which is dovecot-sql.conf.ext.yaml. This file contains some of the configurations we need to go through. The foundation for this file is the database table virtual users we created in video 12.3 of the Postfix implementation. First, we start off with the definition of the config map with the API version and kind. We have a name and a namespace in which we deploy the config map. Then we move down to line 39, where we define the driver for a MySQL compatible database. You even get an SQL command to create a database table, which I am not using. Going further down to line 81, you get some examples of how to specify the connection. You need to define the host database name, the user, and the password for the user. Next, and this piece is important, we need to ensure we are setting the default password scheme. This scheme allows Dovecot to figure out what password encryption scheme to use to log in a user. You can check the different options for the password schemes for yourself on dovecot.org. The link is right in the file. Let us move on to the next piece. We need to retrieve the password for a certain user. That happens under the entry password query. Here we are requesting two pieces of information from the database. One, the username, which we call user, and two, the password. As we have encrypted the password in the database, we need to decrypt that value through the AES function. As we do not have that AES function specified yet in this command, in this SQL query, we need to add it right here. AES decrypt, and we're looking for the password, and we have to enter our database password, which I will not show you on the screen, obviously. Future manual here. The SQL query entered here is missing two small items. At first, I must ensure the password used to decrypt the database entry is not in quotes. I missed that step while setting up the query. The second item is that I have to declare the same as command as I do for the user. If I do not do that, the result of the SQL query returns the field as AES decrypt in brackets password followed by the decryption password. Dovecot will not recognize that as a password field and will deny the login, which is why we assign an alias to this field called password. With that change, we will be able to log in and we can move on to the next part of this video. So back to me, I guess. Once specified, we can move on. As this information is pulled, it is being compared to what is provided by the user. Upon success, the user is logged into their mailbox. That is it for this configuration map. Let's now write and quit. There are 3 more config maps I created based on the original installation. I will not go through them here in this video. They are the LDIP configuration, the OAuth2 configuration, and the OpenSSL-CNF. Especially the OpenSSL-CNF is to create a certificate. As we have one, we will not need this file, but for testing purposes, you can use that config file to create a self-signed certificate. I will post them on my GitHub, and you decide yourself if you can and want to use these files for your deployment. Next, we move over into the conf.d directory. I will go over the changes I made to each of the files. As we have 21 files we have to go through, I will only cover the ones I'm using and modifying. There are 7 files that I am not using and will not discuss in this video. They can all be found on my GitHub, but for my implementation in this video, they are irrelevant. Any options you might miss me discussing here in this video, please review the documentation on dovecot.org. There are way too many to cover them all in a video at a reasonable length. Let's jump right into the first file, which is the 10auth.conf. So let's create the folder confd first with mkdirconf.d, change into that folder, and bring in the first file, the 10auth.conf.yaml. Going all the way to the top and start walking through the file. After defining the same head as per usual in our YAML, we see with line 18 in which we are defining the plain text. Authentication is still active. This feature should be set to yes once you figure out that your implementation works. Scrolling further down, we see the auth mechanism, which is set to plain login in line 108. That option is connected to the previously discussed option of plain text authentication. Scrolling further down, we see how we want to log in and what system we use to manage users. There are several options here. We can use a password file, SQL, LDAP, or system users. We also have the options to set the authentication to static. As you can see, there are also options to deny users. You can specify a list of users that you want to deny access to emails. Where could that functionality apply? Imagine an employee leaves your organization and you don't want to delete that user's emails, but you need to prevent that person from logging into your server. Or you want to punish a kid for not doing their homework. No access for you, buddy. Not speaking of personal experience here, just saying. Potential applications. Another cool feature is the master.conf, which allows any user that is specified in this list to log in as any other user, kind of an administrator. I'm not using this feature and config map, but I see that you might want to. Just follow the instructions in the file and on the dovecot.org documentation. Now for our application we get to line 131. This line is crucial for my deployment as I'm logging into my Dovecot server using an SQL database, which is why I included this file called auth-sql.conf.ext here. We will get to that file next. With the current file 10auth complete, let's write and quit and look at the auth-sql.conf.ext. auth-sql.conf.ext. dovecot-conf.ext.yaml. Bringing in the content of the file, we'll start from the top. We see our standard block for the Kubernetes config map. We specify the password database using an SQL driver. Then we have the details where we will find the database query, which sits in the etc dovecot-sql.conf.ext file, which we covered earlier in this video. Further down, we see the static driver in the userdb section and the arguments being the vmail user and group, and the home for each user is /mail/%n, where %n stands for the user that we pulled from the database. That's already it for this file, so now let's write and quit and move on to the next file, which is the 10 director conf.yaml config map. Pasting the content of the file into our empty shell, we see that a director can ensure that you are forwarded to the same server. That only works, however, in a multi-server setup on bare metal or VM, where you can redirect this traffic. In Kubernetes, we would have to maintain the traffic to the same pod in a different way, hence why this file is a default and contains no changes. So we move on to the next file with write and quit and enter vim 10 logging conf.yaml. Pasting this content, we see our default for config map starting from the top. There are quite some options to log details in Dovecot. That mainly makes sense during your development or if you're managing a Dovecot server on an organizational level. For a home lab, as long as your server works, you can limit the output. However, I like to set the logs to the std out. Why? We had this question in the past video, and the answer is so that we can use kubectl logs followed by the pod and namespace to get the output on the command line. Really easy. The rest should be out of the box and is unchanged, which is why we will write and quit the file. And move on to the 10 vim 10 mail conf.yaml. This file is quite important, so let's take a closer look. As you can imagine, we are looking at the details on where mail is located and stored. Let's take a first look at the different options how to store emails. First, we have the %u, which stands for the username. That contains the full email address. I actually don't want that, but prefer the user part, which is the %n. You can also use the domain part of the email address, which would be to use %d. You have one additional option, which is the home directory of the user. In our containerized environment, where we don't have a home directory, that would not work and we can skip this option. Scrolling down to line 38, you can see we are using a maildir format, which means every email is stored as its own file, and the directory we specify is mail %n. The mail directory we created during the container build, and the %n we just went through, which is the user. Moving on, we get to the namespace inbox. The files are well documented in case you want to create shared mailboxes, but as we are only creating mailboxes for users, I will skip this part. I could remove the hash in front of the type private, but we keep that option as it is. Going down to line 68, and of course we want an inbox. We are planning to set up a mail server after all. The next section, namespace, remains the same, so we go down to line 122. which defines our virtual mail manager to handle emails. As we created a dedicated email manager during the container build, this place is where we tell Dovecot to use this user for email management. If we move down to line 154, we get to the section Mail Processes. The mmap disable is required if you're trying to access your mailbox through different Dovecot servers. As we are running 3 pods with different storages attached, that would not be an issue, but I have taken this option over from my virtual machine. I could remove that now, but will keep it in place as I'm accessing the storage through our synchronization container. As I am accessing the same storage through my synchronization container and the Dovecot instance itself, I will keep it in place. If we go further down, we change the locking mechanism to .lock variant. The reason is our NFS storage. The remainder of the file remains unchanged, such as options for mail handling optimizations, MailDir specific settings, as well as mbox specific settings. So we can now write and quit this file and move on to the 10 master.conf.yaml. The master.conf contains the setup of the services we want to make available. These are, for example, IMAP or POP3 servers and their encrypted variants as well as their configurations. So let's walk through the file. The first setup I took was the service IMAP login in line 24. I am specifying port 143 for the unencrypted port and port 993 for the encryption. I want to use the encryption exclusively going forward, but I had some challenges connecting Nextcloud to port 993 and only 143 worked. I will work on that to make sure that I can use port 993 across the board. I am not defining POP3. I do not want to provide that service, and neither do I want to use port 587 on my Dovecot server. We already established Postfix for that functionality. Next is one of the most important pieces of our Dovecot definitions, the LMTP configuration. We need LMTP to be active and configured correctly in order for Postfix to hand over emails to Dovecot and Dovecot to store the incoming emails in the inbox of our users. First, we define the user that handles emails. As you remember, we did specify within Postfix a user and a group, as well as the same group IDs and user IDs. In Dovecot now, we declare that the vmail user is the one to manage the traffic on this connection. As we are not using a Unix listener, this section is empty. Rather, we get the traffic through the INET protocol. That is the TCP connection we're listening for. We defined the connection already in the Postfix implementation, and now we confirm this port within the Dovecot config. The next 3 sections we will not modify and ignore, which are the service definition for IMAP, POP3 and submission. We get to the section service auth in line 96 within the Unix listener auth userdb. We define that our user vmail is managing the service and the user is allowed to read and write specified by the mode 600. I do specify another INET listener on port 13050 for SSL authentication requests. This listener is specified for user identifications and makes sure only email for users that exists are accepted. That is it for this file, and we move on to the next, which is 10metrics.conf. Write and quit vim 10metrics.conf.yaml. I am not using this function of Dovecot right now, but it might be valuable for you, so take a look at the file and configure its options to your liking. Next, we move on to the auth-sql.conf.yaml. This file contains everything around the encryption and SSL certificates. First of all, we already established in our Postfix implementation that the certificate was copied from our Nextcloud namespace. We continue using the certificate here in our Dovecot implementation. As the secret already exists in our namespace, all we have to do is mount the TLS cert and TLS key in our deployment, which I will highlight when we walk through the deployment in video 3 of the Dovecot implementation. I also use the Diffie-Hellman certificate, which I define in line 70. Those are all the changes to the file, so we can write and quit and move on to the next file, which is 15 lda-conf.yaml. Pasting the content of the file. The only change to the LDA I made is to the postmaster address. Other than that, the file is the default. One thing I want to point out though is the mail plugins in line 52. So let's scroll there. As noted in that area, that is the way to activate protocols in Dovecot such as POP3 or IMAP, mail filters such as Sieve and others. As you can see, the mail plugins option references a variable called mail plugins. We have seen that value before in the original dovecot.conf, where these plugins are activated. So if you want to activate such a plugin, that is where you have to go and do that. That brings us to the file 15 mailboxes conf.yaml. As the name indicates, this file manages the subscription to the mailboxes, such as your inbox, sent items, drafts, junk, and trash. Anything that can be managed by the server. The names are standard, and everything defined in the namespace inbox will be part of your sync. I added auto equals subscribe to each of the mailbox tags. The rest of the file is default, and we will move on to vim20 imap conf.yaml. Most of this file is still unchanged from its original installation. However, one value at the bottom of the file, the mail max user IP connections, is set to 100. Why so high? When we establish a connection, later with a mobile phone or a computer or both at the same time, these logins can add up quickly. A session is established and not immediately closed. That is why the standard of 10 or even 25 are not cutting it. During my testing efforts, and even on my virtual machines, 10 sessions led to errors on a regular basis. Only when I changed this setting to 100, my server stopped giving me errors and worked without an issue. That is already it for this file, and we can move on to the 20 lmtp conf.yaml. Pasting the content of this file, which allows us special configurations for the LMTP protocols, such as what happens if you have a delimiter or to add additional headers to check the quota. Nothing that I want to use right now, but the received header sounds interesting, and I might add this feature and functionality later. Next up is the 20 managed sieve conf.yaml. Managed sieve conf.yaml. This configuration allows you to start filtering and manage emails. The main package that provides that functionality is Pigeonhole. I do not have that activated yet, so no need to configure it right away. The option is there, as you can see, if you want to use it for your own deployment. So we're going to write and quit and get into the next file, which is 20 pop3conf YAML. As I am not using that functionality on my server, there's nothing to be modified. So we're just going to write and quit and bring in the next file. The submissions is nothing, submissions.conf.yaml is nothing that I am implementing in Dovecot. The file is there if you want to implement that differently. So all we have to do is bring in the content, write and quit. But like I mentioned, Postfix is my relay of choice and that is already set up. Next is the vim90 acl.conf.yaml. That file controls how a user has access to the file system. I will not bother, as this functionality is mostly used for shared mailboxes. Nothing I have or plan to set up. Gonna go top, right and quit. And moving on to vim90 plugin conf.yaml. As the file indicates, you must list any plugin under protocols first in the dovecot.conf before you can configure them here. As long as the protocols are activated, you can configure these plugins centrally in this file by adding key pair values. As an example would be ACL equals file. That is currently the only backend that is available for access control lists. Or you define options such as quota plugins with quota grace and the grace you allow, as well as error messages if the mailbox is full. Anyways, that is how this file works. Moving on to vim90 quota.conf.yaml. In this file, you manage how large a mailbox can be. But not only that, you can also specify in this file how large an email can be. If you don't want to receive emails that are larger than, for example, 25 megabytes, you can specify this option here. This file is well documented, and if you want to use these limits, please go ahead and review the documentation and the contents of this file. I am not currently using this functionality, which is why I will move on to the vim90 sievconf.yaml. Again, well documented. I am not using this functionality. I will review these settings in the future, which is why I will move on to the vim90 sievx programs conf.yaml. The C framework allows you to develop your own programs that can validate and process emails. This configuration file helps you to set up these programs. I do not see myself developing or setting up any such rules anytime soon. Gonna write and quit. Reviewing the last file in this setup, which is the vim auth-dict.conf.ext YAML. I did not change this file, but if we look at its content, we see that the file uses the default authentication we have seen in the beginning of this video. This file does contain the reference to the dovecot-dict-auth.conf.ext in the main directory of the Dovecot implementation. However, this current file does not have any impacts on our implementation. This file concludes the review of the files we need to implement Dovecot. Some additional files that are created during the install of Dovecot, but I will not go over, are auth-deny-conf.ext, which allows you to reject the login of a user. auth-ldep.conf.ext, which allows you to use an LDAP database to log in into your mailbox.
auth-master.conf.ext, users can log in as someone else similar to an administrator. auth-static.conf.ext. If you don't need to verify a password or username, you can use this file and specify a static username and password. auth-system.conf.ext. In case you want to allow users on your system to log in a containerized environment, not very useful. auth-check-password.conf.ext. An interface originally implemented by Qmail. This process can still be used, but I'm not sure how widespread this feature is and used in the wild. auth-password-file.conf.ext. This method of logging onto Dovecot requires a file which allows a user to log on onto their mailbox. I don't use these 7 files just mentioned, but I can see in some instances they might make sense. So please head over to my GitHub. The address is shown on your screen, where you can find all of these files. For this video, that was it. As we have not implemented anything yet, the summary will be a bit different. We have reviewed all the default config maps or configuration files for Dovecot except the deployment, which is owed to the fact that we have to review a second container that takes care of the synchronization of emails from each of the Dovecot pods to each of the other Dovecot pods. This setup we will discuss in the next video, where we will create the container and review the config maps we need for that sidecar container. In video 3 of the series, we will then bring both together by reviewing the Dovecot deployment and deploying these two applications into our cluster. Until then, thanks so much for watching, and I will see you in the next video.